At this time, we'll go ahead and turn the call over to Navdeep. Navdeep, please go ahead.
So before we start, I would like to quickly introduce the other speakers on the webinar. We're going to have Deepak Kagliwal, who's Director Sales and Marketing for BlazeClan, also join us. He helps his clients make informed and wise technology investments, which are in sync with their business objectives. At BlazeClan, he's responsible for end-to-end worldwide sales, including sales strategy, sales management, and operations. We also have Philip Van Krenenbroek. Apologies if I didn't get that perfect. He's the co-founder of 5A Box. He's a civil engineer from Brussels University in Belgium and holds an MBA from the Cleric Business School and has a strong technical program management and pre-sales background. Companies he has previously worked for include Alcatel, Motorola, Cisco, and SeaChange, and currently he's the co-founder and solution architect for 5A. So let's start with the session. Data is clearly the new oil. Data in the 21st century is like oil in the 18th century, an immensely valuable yet largely untapped asset. Like with oil, for those who see the fundamental value and learn to extract and use it, there will be huge rewards. Now, if you look at data, lots of definitions of big data, but big data can be typically described basis 3 V's: volume, variety, and velocity, all of which are ever increasing, and recently 2 more got added in value and veracity. Now let's very quickly run through these. Value refers to the business relevance of the captured data and how it will help the business. Veracity refers to the quality of the captured data, and this can vary greatly. Now this is very important as it affects the accuracy of the analysis. Next we have variety, refers to the nature of the captured data. Today you have a plethora of data sources, and so you have a broad variety of data coming in. It could be log data, streaming data, IoT data on one end, or then transaction data. You could, for example, have file data with fixed schema, CSV, Parquet, Avro, for example, file data with which is schema free, so JSON, key value. You could have small files, large files, and I could go on. Velocity refers to the speed at which data is generated and processed. Today, for real-time use cases, we are talking about milliseconds latency. A million reads and writes per second is becoming a norm, for example, for customers in the digital advertising business. And finally, we come to volume, which refers to the quality of the data being generated and stored. The size of the data determines the value and potential insights, and whether it can be actually considered big or not. Customers generating 100 to 150 terabytes of data today is not very uncommon. Now let's quickly come to the evolution of big data processing. On the x-axis you have the speed of analysis, while on the y-axis you have the type of analytics that you can derive basis the same. With batch analysis, it's typically descriptive analytics. Descriptive analytics answers the question of what has happened and why did it happen. It looks at past performance and understands that performance by mining historical data to look for the reasons behind the success or failure. So much or most of management reporting, such as around sales, marketing, operations, and finance, use this type of post-mortem analysis. Then it comes to dealing with data in real time, with which it moves to what is happening versus what happened. Great from real-time alerts, what is happening now, what is going wrong now, for example, real-time analysis, what to offer the customer now, real-time spending caps, transactions get denied, for example, as you exceed your balance. The next is predictive analytics. Predictive analytics answers the question of what might happen. This is when historical performance data is combined with a variety of statistical modeling, data mining, and machine learning techniques, and occasionally external data to determine the probable future outcome of an event or the likelihood of a situation occurring. The final phase is prescriptive analytics, which goes beyond predicting future outcome by also suggesting actions to benefit from the predictions and show the implications of each one of these decisions. So think of a traffic navigation app, for example. You pick an origin, you pick a destination, and then a multitude of factors get meshed together, and it advises you on different routes, choices with a predicted ETA. This is everyday prescriptive analytics at work. Let's get to the next slide. This talks about big data being built for the cloud. Now, big data was built for the cloud, and if you aren't going to use big data, if you aren't going to use the cloud for big data, then you either aren't dealing with big data, or then you're going to struggle if you're not already doing so. Now, with big data, you typically are dealing with very large or then large and fast growing data sets. And with on-prem infrastructure, you will run into capacity issues sooner than later. You have no such capacity issues with the cloud. If you look at the next aspect, with big data, there are typically peaks and valleys, and is rarely persistent volume. And that creates challenges for on-prem infrastructure, as you have to provision for peak loads, which then becomes highly inefficient. The cloud, in contrast, is most efficient with highly variable workloads. Now, when we talked about the variety and velocity of data, you have a multitude of tools available in the cloud today to deal with structured, unstructured, semi-structured data, batch data, stream data. Now, you could come back and say those tools are available to use otherwise too, but then the challenge is that it's not about using those tools, it's a lot about managing and deploying those tools. And that's where we have the AWS cloud, where all of these solutions or tools are available as fully managed offerings. Now let's look at the big data pipeline. Before we get to the components that enable this, it's important to emphasize that it's imperative to start with understanding the use case, or in other words, the answers and insights that are required, why they are required, and how they will help the business before embarking on building out solutions and piecing together the elements to enable it. What's important is leveraging the data. The technology exists today to make it all happen quickly, securely, and cost efficiently. Now let's look at the pieces. I'm going to cover a few of them very quickly in the subsequent slides. So if you look at the ingest and the collect phase, we have now Kinesis, or the Kinesis family of products, which helps to ingest streaming data. We have Snowball, which is an appliance to move tens of terabytes of data into the AWS cloud. You have Direct Connect, which helps to establish a connection between your premises and the AWS cloud. And then you have now the data migration service, which lets you move on-prem databases to the cloud, or then even migrate to a different database engine. Then you have S3, which is our highly durable and cost-efficient storage. Again, Kinesis Streams, which I talked about. This is another variant of the Kinesis family of products. In databases, we have RDS, which is a managed database offering, supporting Oracle, MySQL, SQL Server, Postgres, MariaDB, and also Aurora, which is our own database engine. And then we have a NoSQL database in DynamoDB. Coming to the process and analyze phase, we have EMR, which is a managed Hadoop framework. We also have data warehouse in Amazon Redshift. We have machine learning. Now that lets developers of all skill sets very easily use machine learning. We have managed Elasticsearch in Amazon Elasticsearch. And then we also now have a BI and data visualization tool or service in Amazon QuickSight. I'm going to cover a few of these really quickly so that I give enough time to the very interesting speakers after me for their session. So let's just come to Redshift. I'd just like to point out a few things here. It is a fast, fully managed petabyte scale data warehouse. Now it's fast because it's optimized for data warehousing. Redshift has a massively parallel processing architecture with columnar storage, data compression, and a 10 gig network between the nodes for up to 10x data performance, a better performance than traditional row-based stores, so perfect for OLAP type workloads. Now it's also very cost effective. There's no upfront fee, absolutely no upfront fee. You only pay for the resources you provision. You can start as small as 25 cents per hour for a single 160 GB node, and scale up to over a petabyte for under $1,000 per terabyte per year. And this is compressed data. So when you look at it without the compression, it's cheaper. So this effectively translates to Redshift being a tenth of the cost of most other data warehousing solutions that exist today. Now it's a fully managed service, and it's it's very simple to get started with. It's fully ANSI SQL compliant, so you can use your traditional BI and ETL tools with it as you do today, and we have all the compliances in place. Let's move to EMR very quickly. Now EMR is simplifies big data processing by providing a managed Hadoop framework that makes it easy, fast, and cost effective for you to distribute and process vast amounts of data across dynamically scalable EC2 instances. It is not about Hadoop anymore. We also support Spark, Presto, and now Apache Flink. A little known fact is that we are the largest cloud operator of Hadoop infrastructure today. We support the open source distribution as well as the MapR distribution. We are also probably the most current Hadoop distribution in the market today. So we have the latest version of the most popular apps in the Apache Hadoop ecosystem being available out of the box with EMR today. We come to the Kinesis family of products. We have 3 products here. We have Kinesis Streams, which not only helps you to ingest the data, but you can build custom apps on top of it to process and analyze the streaming data. We have Kinesis Firehose, where the mandate is essentially to very quickly and easily move massive amounts of data, streaming data into our data store, so S3, Redshift, Elasticsearch, and then Kinesis Analytics, which lets you then analyze the streaming data using standard SQL querying. Next, we come to Amazon Elasticsearch. Now, this is a managed Elasticsearch offering. We offer the native Elasticsearch API, so very easy for you to port your existing Elasticsearch deployment onto Amazon Elasticsearch. We support ELK, so we have a built-in Kibana, for example, here, and we have Logstash connectors to make the ingestion easy. Again, a fully managed service. The next slide, we talk about a select set of our big data and analytics customers. We have customers now across startups, enterprises, and large institutional users. You'll see many familiar names on this slide. We have many of these services which I talked about earlier available also now in the Mumbai region apart from Singapore. And I would now like to hand this over to Deepak with highlighting the fact that it's absolutely essential that you start considering leveraging the data that your business probably generates today, and it's extremely easy to do that today with the AWS Big Data Analytics offering. Deepak, over.
Thank you, Navdeep. So basically, what we're looking at here is, the subject is vast. There are various tools available today. So we'll just deep dive into, how you can use cloud and specifically AWS cloud for real-time big data analytics. We saw you can use it for various use cases, including, doing batch analytics, including using your data warehousing. But looking at closer towards how do we use big data for real-time big data analytics. So we saw some numbers from from various sources, right? Today we are seeing
almost we're not talking about trillion, we're talking about numbers which are really exorbitant, right? The good part is, the staggering part is, almost 90% of the data that you see in the world is being generated only in last 2 years, right? And with the not so good part is only less than 0.5% of it is currently being analyzed and used. So we really know the value of data, what is the potential that you can use to analyze it. I mean, it could bring immense value to your businesses if you start analyzing it in the right way. I mean, we spoke about few problems earlier, and we spoke about some problems, right? What are the current problems that businesses are facing? Today, even though organizations are very fast in adopting new technologies, they have adopted big data in some sense or the other, but due to some regulations or due to some internal change management, they're still using the old systems on premise, which actually can't cope with the speed at which the data is ingested at various business points, whether it's in your factory using IoT devices, or whether it's the ERP system that is generating data, whether it is your CRM systems or your e-commerce systems that are generating data, right? And it's very difficult to scale on premise. Second is the cost. I mean, if you would want to do the same thing on prem, it is very cost. It's not at all cost effective to build those systems on prem. There will be huge capex investment that will be required. And third, of course, is the tools that are there on prem are not built for the modern architecture. They're really outdated, and in the traditional way the analytics is done, a typical project would take more than 6 months to 1 year. So what does cloud provide us, right?
So all these problems we can really easily, overcome by using cloud. Cloud, specifically AWS, has built for scale. Today at AWS, you can scale to any level at a very low cost. It will also give you, because it is priced per hour. You can actually define your budgets and spend the amount that you have. I mean, that's the way you can have a lot of control over your spend. The third thing, which is one of the most important thing, is cloud actually enables you to fail fast. What do I mean when I say fail fast? For example, you want to try out something. You want to try out, the sales department wants to try out which is the fastest moving item in the inventory. Now if I were to do it on prem, probably it will take me ages, right? So cloud enables you to really do a very quick dirty POC, because the servers can be spun within minutes. The services that Navdeep spoke about can be enabled within minutes. You can try out a quick POC in less than a week. Philip, in the later part of the presentation, will talk about how we have enabled them to really go to market in less than couple of weeks. 1 week, 2 weeks is what we're looking at max. So that's how AWS actually enables you to really move very fast in the value chain, be ahead of your competition at a very low cost. So these are the few advantages that you get when you do analytics on cloud, right? So how does BlazeClan come into picture? I'll just give you a brief of what BlazeClan is. So BlazeClan is we're the premier consulting partner for AWS. We have been receiving a lot of accolades and awards from various industry stalwarts, including AWS. For example, we have won the Customer Obsession Award twice in a row from AWS, which talks about the way we work with our customers. We have various kind of services. Typically, when it comes to big data analytics, we're looking at services which are more on the advisory front. For example, I spoke, you have a use case, but you really don't know how to use it. How do I use the various services? So we have a cloud advisory arm that we have a team of consultants that will actually come in, and analyze your business use case and give an approach for you to how to move to cloud and how do you use your existing algorithms to run on cloud, what it will cost you, how much time it will take, a typical consulting engagement that we drive with you. Of course, once you have the entire plan ready, then you would actually need help in in deploying it on cloud. So that's where our migration and deployment services comes into play, which is not only true for big data analytics, but also, for example, you want to move your ERP apps, which is including your SAP, your Oracle, your CRM apps. We actually help you to migrate them all to cloud. Now, one of the critical things when we use cloud is how do I automate? Because what I want is really make it very foolproof. We don't want a management overhead. So, for example, we have customers that are using cloud for they're an ISV and they want to deploy their solutions to customer within a day. Now, how do I enable that? For example, I need to have a very high-end DevOps enablement done so that one solution that I am deploying for customer A, I can deploy the same solution to customer B in less than a day's time. So all the base configuration is done, and you don't have to really worry about how do I. It should not take the same amount of time it took me for customer A to deploy a solution to customer B, right? And typically, what we have seen is, a lot of organizations once they have their entire setup on cloud, they require monitoring services, they require patching services, they want to manage security services so that their data on cloud is secure. That's where our managed services comes into play, and we give an end-to-end 24/7 high-end, very automated SLA-based managed services. What we have done from the analytics standpoint is based on our experience of last 5-6 years. We have grown so fast. We are born in the cloud company. We call ourselves as BIC. We do nothing but cloud. We have a global presence. We started with India in Pune. We have offices in Bombay, in Southeast Asia, which is Singapore, Malaysia, where we have a team of experts sitting in both in Malaysia and Singapore that helps local businesses to scale. We have now expanded in Europe and US. So any global business, no matter where you are, we have a team to help you. In the process, what we have done is we have built a lot of solutions around AWS services, a lot of solutions around frameworks that actually helps you to really build your use cases very fast. Which also includes, if you want to build a small app, which is cloud native product development, we help you to build that. As I said, we have built a lot of frameworks. For example, we have a framework for media companies, which is, complete, we call it as Cloud Stream, which helps you to, mostly from a video standpoint, it will help you to ingest your digital content, have an asset management on top of it. You can publish your videos across, various publishing frameworks, and then you can analyze your data or videos on demand. We have built a product called as Cloudlytics, which is actually a cloud management platform and a framework for big data. It helps you to monitor your cloud, spend usage, again do automation on regular tasks, and I'll cover the engine in detail in my next slide, which also talks about how do I, if I have a use case, how do I fit in the engine and really move very fast. We have built a load testing tool in case you want to do a lot of load testing on cloud. It's called as Cloud Scale. It runs on an open source framework of JMeter, but it scales on cloud and actually helps you to automate your entire load testing on cloud. And specifically, we also have built a NAS solution for cloud, which is called as BlazeNAS. So these are some of our frameworks. I spoke about the big data engine that we have built. It's called as Cloudlytics 2.0. It actually helps you to analyze data from various sources, have a core engine in place, and then have a visualization layer on the top. So typically it's again the diagram that Navdeep explained is ingest, then transform, and then visualize, right? It gives organizations a lot of kick to really start their projects very quick and do show some quick POCs and then convert that into a production level workload. The engine, as I spoke about, is basically the entire framework where we have an aggregation engine where you can actually take in data from various sources, which includes, Amazon Kinesis, Kafka. You can use, if you're very open source centric, you can use Kafka. If you have custom API layer, you can take data from the APIs. If you have data stored on your S3, you can pull in data from S3, right? So your aggregation engine is basically where you will start collecting data. Then we have a transformation engine, which is built on custom wrappers. It has multiple layers of transformation. So for example, if you have a lot of log data, you can transform it using Logstash. If you have complex transformation, then you can use AWS EMR. You can use Talent, which is an open source ETL engine, right? After that, we have a querying engine where we actually help you to query your data. Typically, we use AWS Elasticsearch, which is built on the Elastic framework, and plus you can have a custom API layer for querying. Once you query your data, which is already transformed, you need to visualize it. Now, visualization could be by default we have given Kibana, but if you really want to have your own visualization tool, for example, if your organization is using Tableau or ClickView or AWS is launching QuickSight. So it can work across any visualization engine that you tool that you have, and you just have to plug in the visualization tool to our querying engine, and hence the entire flow is complete. So essentially, what we are saying is, the entire end-to-end, right from your data ingestion to transformation to querying and to visualization, is packed in a very automated way. In a very, the engine is built very beautifully so that you don't have to worry about the scalability. It is already on an HA mode, so you don't have to worry about the reliability of the engine. You can just start getting it, start pulling your data, and then start using the entire end-to-end analytics engine that we have built. Now, I would like to hand over this to Philip to talk about the case study for 5A box that we have built for 5A box. Over to you, Philip. Thank you so much.
So we are basically a European, Belgian-based company that are providing within the IoT space, solutions for companies that want to gather data, for a variety of industries, like for example in the energy space, but also for home automation and domotics. And we also do some remote VPN or request solutions. We are the physical part of this whole big data solution, meaning that we are connecting to physical sensors and even actors and gathering all the data and sending them into the cloud, where BlazeClan is then handling all the rest and doing the smart stuff. What is important for us is to provide that data in a high quality, reliable and an open way. What do I mean by that? People need data in a continuous way. That means there will preferably will be no gaps. So we are in charge of, with our gateway, to make sure that there is continuously a data feed available for the cloud. Quality-wise, we have split the data into two parts. Essentially, we're talking about metadata and data. Metadata is the part describing what the data is all about, meaning, for example, in the world of energy, is this power, is this voltage, is this current? Yeah? All of that is part of the metadata information. Later on, when we then upload the data in batch or in stream format, yeah, the mapping or the interpretation of the data is done automatically because the platforms are already aware of what the data is and how it should be interpreted. As we said before, what is the challenge? In essence, you need to stream data real time for some customers, in batch for other customers, to allow them to gather that information and make it available to the cloud. I just want to come back to the open aspect, in the sense that what we do from a real-time point of view is that we send the data to the platforms in what we call Mosquito or MQTT bearer. That means we use MQTT to allow data to be live streamed to the platforms. Now the complex transformation basically comes into play when we're talking about, okay, what do we do with the data? And in that sense, like I said before, we provide metadata describing the data and then the data that's coming afterwards. The integration was done in a very quick and swift way, because on top of all the rest, we provide an open interface, an open API that is in detail described, that allow people like BlazeClan to integrate seamlessly with our solution in a very clear and open way. All the rest, the data, what needs to be done, I think, that is the more intelligent part of the whole system, what BlazeClan was referring to. So what do we do with all the data? We visualize it at first. That was also one of the challenges in this case study, that the person or the company wanted to see or visualize the data that was gathered through the 5A box. There is a myriad of data that was gathered, in this case from a building, whereby the data consists out of, for example, weather information, also about energy information, voltage, but there was a lot more that we could gather. We focused on some of the aspects that were the most interesting ones. You will also see that the data can be in a continuous way, or can be also a bit more fluctuating, in the sense that only upon change the data is transmitted to the cloud. It is then funneled to the 5A box gateway at the IoT device that transforms the data that is in this building specifically built on KNX, into a more generic format that allows us to transport the information over MQTT to the cloud. As a result, we were, like was already mentioned, in a very short time frame, we were able to quickly visualize the data that was available for that building after a time span of at the very most 2 weeks. So the first graphs were created after a couple of days with some fine-tuning and some optimization. The whole project, the whole case study was available after 2 weeks. What is extremely fast in terms of integration and providing a solution for the customer. I think most of the technical architecture that was involved from a cloud perspective, I will allow BlazeClan to comment on that later, but in essence, the data came in And through a variety of processes and layers, yeah, this was then transformed into what we call a visualization part that allowed us to, via a web interface, to have access to that data in a very clear and open way. So you see, although the complexity, underlying complexity is there, but because of the strength of Amazon, of BlazeClan, we were able to transform that into something that was also very simple to the end customer. Yeah, and that's in essence what we were talking about. So I'll give the floor back to Jerry.
We do have 4 polls open for you, 3 at the bottom and 1 at the top of the screen there. So please feel free to fill those out during our Q&A. Remember, keep submitting your questions.
I think Philip answered. I would like to understand question from Rajan, which says, I would like to understand the 5A box achievement. I think, as I said, 5A box have actually helped in the speed and ease of integration. So BlazeClan has helped 5A box to really move very fast, understand the data, do help with integration, and then build dashboards on top of it. So that's the business value that we bring brought in for 5A box. How much modifications have we done to the ELK stack? The answer to this is what we are providing is not only an ELK stack, but also a lot of additional to an ELK stack. For example, we have said that you can actually run a EMR job to do transformation, or you can have multiple. Not only for the ETL part, you can also have traditional sources using talent as a data source. So those are the things that we have added to the ELK stack, so that the overall frameworks becomes much more powerful and you can utilize it to the fullest. So you can add lot many more components other than just the ELK stack. And I see from Raghav, can you talk more about the architecture? Yes, I mean, guys, you can also send us an email to sales@blazeclan.com if you want specific help on the architecture point of view. But to give you a view, the architecture is the same as what I've spoken about. The overall framework, which has typically components of the querying engine, which will have either using Logstash or EMR, and then you have the analyzing engine, and then you have a visualization engine. But once we share the slides, I think the architecture will be much more clearer to you. Geetika says, is this solution available with some standard workflows? Yes, when I say standard workflows, all the components are already integrated. The only thing that you need to do is let us know your data sources from where we can pick up the data. Then typically the entire flow is very much automated. The things that will change is your ETL jobs on the one side. In middle, your transformation rules might be different, right? So the transformation rules would change. Visualization, of course, is very customer specific, but the solution is integrated with all the workflows that are required. So you don't need to spend time in building those. Thus, Kinesis will be better for building real-time recommendation engine. 100% yes, because the primary requirement of a recommendation engine is to have data in real time. Now, the only way to get data in real time, is to have a stream of data coming in, and that can be achieved by using Kinesis very effectively. To give you an example, if you are say building a recommendation engine, if you are a CPG company and you want to build a recommendation engine for your store, or even if you are an e-commerce company and you want to build a real-time recommendation engine based on the buying pattern of your customers, then you need to understand the behavior, their social profile, and that will all come in real time. For example, if somebody is buying say baby diapers, you know that person will definitely buy say a baby powder, and then that is how you will be able to recommend them in real time. So Kinesis is the required component there, and you will require to set up Kinesis stream to get in the data in. What is the time estimate for real-time recommendation? I think, as we said, depending on the use case, but we have built, as Philip said, we have built the entire five-way box use case in less than 2 weeks. So that's the speed we are talking about. Of course, it could take more depending on how complex or how elaborate dashboard requirements you have. But rest assured, it's a very fast way of to test out your POCs or some use case that you have. We can do it in a couple of weeks time. I think I've covered most of them. Time for setup, I think Philippe has already answered. It's an engine which is already built. Setup doesn't take too much of time. Again, Ankit has shared a question which says, can you help with some best practices? Definitely yes. What we have done by building the solution is keeping in mind all the best practices for cloud. Typically, the best practices that you look at is one is it should be scalable. Second, it should be designed for failure. For example, it should be always in an HA mode. Third is it should be pay per use, right? Fourth is it should be secured. So whenever we build the solution, we will take care that all the basic principles and fundamentals of cloud best practices are taken care of, and that's how the framework is entirely built on basis of best practices. We can also share some best practices documents for you with you. There is a lot of data that is already available on AWS website. So if you just go on aws.amazon.com and search for best practices for security, best practices for deployments, you will get plethora of documents that can be used while building such solutions. Yeah, I think there are no more questions. Yeah. I think we're done with almost all the questions. Jerry, any more questions do we have, or do we take them offline if we get more?
Yeah, I didn't see any other questions. It looked like we covered a lot of them. So if you like, we can go ahead and end our Q&A, or we can pause a little longer so if you have any last-minute questions come in.
Okay, I think we have one more question from Shweta, which says, how is Kafka different from Kinesis? So, Kafka is an open source, streaming engine. Essentially, both are streaming engine, which is used for the same purpose, whether it's Kafka or Kinesis. Kafka is open source, and Kinesis is a product by AWS. It's a service by AWS. So essentially, you don't want any management overheads. You want a fully managed service, and which is managed by AWS. You don't have to worry about the security. You don't have to worry about the entire architecture. Then I would strongly recommend that we go with Kinesis because it is a fully managed service by AWS. But basic functions are the same. But Kafka is an open source, so there will be a lot of management overhead in terms of installing, managing the entire Kafka service on AWS versus using it Kinesis as a service to really deploy the streaming engine or the stream for your data, real-time data.
All right. So we'll go ahead and close down our session then just a little bit early, give a little bit of time back for you. Again, thanks for taking our polls in the middle of the screen there. Thanks for joining with us today. We do appreciate our presenters and panelists today on our call. At this time, everyone can disconnect from the session. Again, thanks for attending.